Thank you so much for joining us for this, what promises to be a very exciting discussion. It's coming, of course, at the end of 2 days of some high intensity action across different topics and sectors, bringing to you some of the sharpest minds discussing cybersecurity, discussing payments, amongst other things. And today we are here to discuss something very big, the future, really, as far as power is concerned. What is the future of power? The theme that we're discussing today is IT and OT integration in the energy landscape. I want to dive right in, bring in our experts, and put some thoughts together on the panel today. First and foremost, we have joining us Akilur Rahman. He's the Chief Technology Officer, India, Hitachi ABB Power Grids. We have Upendra Tripathi, Director General, International Solar Alliance. We have Biswati Biswas, Executive Director, Infrastructure, Government and Health, IGH, KPMG in India. We also have Amit Jain, Senior Energy Specialist at the World Bank. Gentlemen, thank you so much for your time here today. What an exciting time to be talking about the future of power. There's so many changes that are taking place. And I would like to kick off today's conversation by really starting there. When we're talking the headline in terms of all the changes that are taking place around us, all the changes that we've been forced to really undertake, if I can call it that, given the pandemic, all the announcements we are hearing, the big announcements from the government when it comes to their push as far as power and energy is concerned, a lot happening. What in your mind, perhaps, then, is that future really looking like? Akilur, if I could maybe come to you first.
Okay, I think in addition to this pandemic situation, we also had several transformation and also the trends which were seen in this space. If we look at energy, electrical power, I think there are three or four important elements, the segments we have to look at. First of all, the utility, the energy utilities itself. And then the second one is the industry, and then the third and the fourth one is basically the infrastructure and transport. And looking at the big trends in the utilities, we have the renewable penetration of renewable, making the entire space carbon neutral, and also then energy internet, smart grid we are talking about. In the industry side, we have Industry 4.0, fourth industrial revolution. We have collaborative manufacturing. Then we have real-time optimization of manufacturing. This is what they're coming. And on the infrastructure side, smart cities we are talking about. We also have the electric mobility, which is a big ticket item for the country, for the industry, for the utilities, and also the mobility as a service. If you look at all these three, four segments, power, energy is common denominator. And also there, the core technology of the power, energy, and automation and digitalization is common. I think that is how we have tremendous opportunity to improve the performance of these sectors with combining the OT, the core technology, power technology, the automation with digitalization with IoT. I think that's the main theme here. Yeah.
Sure. And you're doing a lot of work in that area. We'll come back and discuss some of the specific solutions that you have there. Mr. Tripathi, I would like to get your opening comments as well.
If you look at COVID, the policy response globally, some countries have been more lucky now in the sense that COVID is under control, but globally the response has been massive. For example, the next COP at Glasgow in Britain, it's coming up, many new ideas. One of those ideas is the World Solar Bank, which means how you can challenge, the industry, the challenge for capital at low cost can be met. And the Glasgow at COP26, we are also talking about the one sun, one world, one grid. The perimeter is around 40,000 kilometers, but this is going to be much longer than that. So technology, artificial intelligence, the latest state of the art, everything is going to be fused in this global project, of which the feasibility study is underway. And the third thing that we are talking about is a massive global response, to promote solar, renewable in general, is something called Green Grid Initiative. Essentially, we are saying that government support is not enough. You need support from NGOs, you need support from civil sector, you need support from private sector, and most important, you need support from legislatures. So the International Solar Alliance to promote the World Solar Bank and to promote this global project called One Sun, One World, One Grid, which uses essentially time as a battery, is partnering with Climate Parliament to get legislative support. So in nutshell, the COVID has actually brought a new normal. And in this new normal, the global response, policy response, has been very massive. We are coming up with brand new ideas and in brand new areas, and where technology can be used to maximum extent to address climate issues. Thank you.
Sure, sir. Would like to discuss a little more in detail on the One Sun, One World, One Grid initiative. We'll come back to that, but Biswadeep, I do want to give you also the chance for opening comments.
See, the Harvey Nash survey that has taken place in 2018 has observed that the power and utility companies invested in smart meters even before the term Internet of Things existed. So this survey that involved nearly, say, 4,000 companies across 84 countries, including 98 IT leaders in the power and utility industry, found that the sector has invested more heavily in IoT than in any other industry, and is also at the forefront in the investments in artificial intelligence and machine learning. So some of the important figures that I can tell you is about that. There's almost power and utility companies have invested more heavily in IoT, almost 48% versus 21% across industries. They have also made significant investments in AI ML. It is almost like 29% versus 24%. Now, when prioritizing digital investments and IT/OT convergence, power and utility companies are heavily focused on improving the business process efficiencies. 72% versus 54% across all industries. The focus is much less on attracting new customers and growing revenue from existing customers. So this is the figures that tell us from the CIO survey conducted by Harvey Nash and KPMG. Over to you.
All right. Sure, sir. And those figures are definitely looking positive, at least when it comes to the number who are saying that they're doing some kind of investments. Before we go any further on that, though, I do want Akilu to step in and talk about, some of the products that products and services, really, if you could talk to us, which are the intersection of IT and OT. Akilu?
Okay, I'll just take a cue from Biswajit, what he talked about. I know power sector has been a forerunner in adapting IT. I remember, personally, when I was doing my master's 32 years back, my project was digital simulation of a HVDC network, multi-terminal high voltage DC network. So power system, I think, is probably the first one where in a large scale using the IT for simulation, for control, for monitoring, and system like network of different devices, sensors, applications. And thereon, I think we had been using IT for the SCADA, having the sensors, and also the edge computing. What we are talking about today, it has been there actually 2-3 decades. We were saying it's intelligent electronic device, the protection and control devices, which lot of scientific algorithmic computation, it takes place in that box. It's like edge. So here, I think now going forward, we are going to extend those systems, whether it is a network manager, network control, SCADA, PLC, having all the different devices, equipment with sensors, with communication equipment, extending that system with IoT so that we can take the data to the cloud. By having the data on the cloud, then there are multiple stakeholders who can access the data, who can combine the data with weather data, with consumer demand, with prosumer demand, with weather forecasting, how we can generate the renewable, the solar, the wind. So by combining all these data, they can do analytics, they can apply artificial intelligence, machine learning to have better predictability in the energy system. Predictability in terms of the generation, the consumption, and we have seen that actually the COVID has given us a situation where suddenly there is a disruption, the power, the consumption, the industrial production is down, and it has to be now managed dynamically, and it has to be
Okay.
efficient. It has to be like the 9 p.m. the lights off event. So we have to manage it, and in a power system, it cannot be done by human intervention because it
Sure.
works in milliseconds where
Okay.
the human cannot react. It has to be machine, it has to be system which has to react to the situation of the power consumption in industry, in infrastructure, in the utilities. And that is why it is very important now, in addition to the core system of the primary equipment, the systems, the network, the automation, the SCADA, we also build this IoT platform to have better predictability in the system, better efficiency, and also having a lot of renewables in the system, which can
Okay.
make the entire system more efficient. Yeah.
Okay. Before we go any further on this panel, it's time to take the first poll question. And for those of you watching, you need to respond yes or no. And here's the first question. We have two more coming up over the course of this conversation. The question is, does India have adequate regulatory framework for prosumers? Yes or no? That's what you need to send in. Do let us know your thoughts. Let me quickly also then come to Mr. Tripathi. Sir, I want to talk about the role of IT when it comes to the kind of capacity we're talking about for solar energy. Headlines suggesting nearly 55% of the total installed capacity by 2030 will come from green energy and renewable energy sources, really. What, in your mind, then, and what, in your opinion, is going to be then the role really of IT and technology in this?
Yeah, in fact, the role of IT, my anecdote started with that. The engineer who had fever in Chennai had actually delayed the repair of the solar panel, which was upside down near Asgard. Now, that indicates, the small role that I talked about. But when we are talking about IT and artificial intelligence coming together, we're talking about transformation. And the type of both artificial intelligence and IT, they can play in a whole supply chain of the solar industry. And where IT can play a role is this. There is always a challenge called how to reach 100% efficiency, and IT will have a tremendous role in this, not only for managerial efficiency or even technological efficiency of the silicon panels that we are talking about. There is always a challenge about how to consume 100%, the type of smart metering, smart distribution we are talking about. And there is a challenge where IT will play a role, and it's called how to store 100%, the storage industry that we are talking about, and the type of connectivity of both artificial intelligence and IT we are talking about. And there is also a challenge as to how to distribute 100%. And the distribution transformation, technology we're talking about, energy efficiency where IT plays a role, and even smart meters where the value of IT is more than the value of the hardware. And then, of course, there is a challenge called how to transmit 100%. And when we talk about these challenges, we are essentially talking the role of IT will be challenge. And if you put a box called IT, and out comes the opportunity. So IT will play a very significant role in converting the challenges to opportunities. And this can be true in the context of global demand aggregation, as Solar Alliance is doing. We took some 272,000 pumps from 22 countries, went for a global tender. Now, even the type of irrigation they will provide, the type of training, everywhere RT is playing a role. And today we are training 35,000 people, stakeholders, without actually physically getting that. It's all in cyber mode, in virtual mode. And that is the role of IT's reach. We're talking about training farmers in 89 member countries. We're talking about training journalists in 89 member countries in energy journalism. So the reach, because of IT, it has become, fabulous. So when we are talking about challenges and opportunities, whether we are talking about 3 billion women, people with no drinking water access, or 2 billion women with no clean cooking medium, or 700 million with no energy access, IT is going to play a tremendous role. So to sum up in one line, IT's role is so vital. It is important to convert all challenges into opportunities for the industry, and that is the role IT is going to play. Combined with AT, it is much more powerful. AI rather, sorry.
Sure. Speaking of those opportunities, one of the most critical, if I can call it that, stakeholders when it comes to renewable energy, of course, is the government and the role that the government plays. I want to reference the recent comments made by the finance minister in the budget when it comes to duty on things like solar inverters, solar lanterns, etc., to try and boost really domestic production and domestic manufacturing. This is open to the entire panel. How are you really reading those comments? Does it excite you? Do you think that perhaps this is going to inch us slowly towards the goal that we have when it comes to renewable energy? Biswadeep, maybe I could come to you on this first.
See, right now the focus and the objective is to bring renewable into the grid,
Mm,
right? So the problem statement that is there for bringing renewables into the grid is that we need to have very strong regulatory framework so that they can participate into the trading that happens into the grid ecosystem.
sure.
Now, there comes the possibility of opening up new OT technologies, which can, all these cyber physical devices that are connected into the renewables field, they can trap all the parameters and they can put it
Mm,
into the blockchain, and this blockchain can be wholly integrated within this IT network. So what we are trying to say is that there has to be a couple of things. One, a strong cyber security guideline, and the second
okay.
is the proliferation of the IT/OT convergence in bringing this renewable data parameters, efficiency, proficiency, process improvements, and play them eloquently and getting them injected into the grid.
Sure. Do either of you gentlemen want to take a stab at that? Mr. Tripathi, I see you nodding. How are you really reading those
Yes,
announcements?
but we do not comment on individual
Yeah,
countries, but
yeah,
uh, about either fiscal or financial
sure,
policies. But generally, we do appeal to all our member countries to have such fiscal and financial policies in place, which gives a boost to solar energy in the interest of the climate justice or climate goals that we are talking about.
sure,
Uh, uh, that's all that I
sure.
had to add from my side.
Okay. Akilur, one of the things that Mr. Tripathi was mentioning briefly is the kind of challenges we are looking at when we're looking at this massive opportunity that is going to be created. What are some of the challenges as you foresee it when we are talking about bringing, really technology, IT, OT, machine learning to smart grids, to power, to the future, really? What are one or two of the top challenges? How do you perhaps foreseeing the industry really overcoming those?
Okay, I think it's about the economics of it.
Yeah.
So we always traditionally the industries, the utilities, they have been always looking at the capex and then saying that okay, whether it is expensive or it is economically viable or not. But we have to now look at the life cycle of these the systems, the utilities, the renewables, and also the operation of the grid as a smart grid. When we look
Sure.
at actually the very concept of digitalization, IoT can actually make it viable because you don't have to spend capex in the beginning, and the business model will evolve in a way that you subscribe to all these applications, the data, and you have the apps, so AI ML based apps, which will do the prediction of whether it is asset health, or the operation in
Sure.
terms of the SCADA, the renewable, the forecast. So that way you can monetize it easily and you can justify. I think that's the mode we have to go into, and also the policies, the procedure, the business model has to be around that. I'll tell
Okay.
you, some example of, let's say we have this T Expert, which is a transformer digital solution. I mean, transformer is a very, very, important equipment in the system, and it handles, hundreds of megawatts. And any malfunction, any failure of the transformer can actually impact the power evacuation to the system or even delivery to the system, to the consumers,
Absolutely.
prosumers.
Sure. I just want to also welcome in at this point Amit Jain, Senior Energy Specialist at the World Bank. Amit, thanks for joining us here. Really talking about the future of power. And I would like to ask you to really talk about the fact that we have heard the announcement as far as the one sun, one world, one grid is concerned. But I would like to ask you to talk about the intersection of technology, the intersection of IT and digital when it comes to this, when it comes to the one sun, one world, one grid. What would you really like to tell our audience?
Thank you very much, and my deep apologies. I am late. But let's take a step back before we come to the one sun, one world, one grid concept. 10 years back, before the National Solar Mission was announced, Gujarat government had a Charanka solar park coming up, and then now we have Reva solar park and several other solar and wind installations on gigawatt scale coming up in India and throughout the world.
Sure.
So 10 years back, if somebody would have asked us what the future of power looks like, we will be struggling with questions on CSP or PV or solar or wind 10 years back. I'm talking about 2009 and 2010 when National Solar Mission was announced. At that time, the question you're asking me right now in terms of information technology and OT would have been premature, right? It's because we are talking about future of power. So now if we do a time travel, if we have a time machine and if we go 5 years or 10 years down the line, what are we looking at, right? We will be looking at a solar rooftop on households in India. That solar rooftop will be feeding to my house through net metering, and it will give surplus power to a battery, which will then feed to a charge controller to my electric vehicle car. This is the future and convergence of technologies we are talking about 5 years, 2 years, 7 years down the line. You see the history, the journey we have done from 2010, 2020, and now in the next 3 to 5 years. When this convergence of technology happens, the electric vehicle, the charging station, the solar rooftops, the net metering connection, how do you maintain all these things? Through IT, through a smart meter, through a convergence of technologies who can manage the inflow and the outflow of electrons, right? Very simple example. I just installed solar rooftop on my house last week. It is coming with a smart metering device. Now, it will tell me how much electricity I'm consuming at a particular time of the day. When am I going to switch on my washing machine? When I'm going to use a refrigerator? And how can I reduce the consumption by switching it on or switching it off at a particular time of the day? At the same time, it will also tell me how much electrons are being generated by solar rooftop and how they are going to enhance and cut my electricity bill. So information technology is going to the future because we are talking about convergence of these complex technologies all coming at a household level, impacting a common man.
Okay. All right, we'll discuss that a little more in depth. I just very quickly need to take our second poll question for our audience members. You need to respond yes or no. And here's the question for you coming up on your screens. Is smart grid the next enabler for effective management of renewable energy? I'm going to repeat that. Is smart grid the next enabler for effective management of renewable energy? You need to answer yes or no. Akhilur, let me come to you on this next question. I do want to ask you and try to understand from you, the grid of the future. It's really going to be talking about renewable penetration. What is your suggestion about how this is really going to pan out from an industry point of view? Previously and in public comments and reports, you have spoken about this. HAPG has spoken about this. What really is that grid really going to talk about? We're talking smart grid, of course. What is that going to look like?
Okay, so I think it's with this penetration of renewable and carbon neutral operation in the industry, in the infrastructure, in the utilities itself, and also the transport. It's going to be system of systems and sort of systems which are decarbonized, decentralized, digitalized, but at the same time they work in cohesion. I think that's the reason why we have to have a very strong automation framework and also digital framework for this. And coming to industry, I think it's about earlier it used to be that okay, industry they were taking power from the grid and then they will have their own captive generation. Somehow they will manage that. and many a times they will have equal backup DG power for their operation, because they don't know when they will not get power. But today they have several options of having the renewable power wheeled from the grid, so they can have contract with the companies which are providing the renewable power through the grid, and they can have their own solar PV, for example, in the industry, in the plant. They can have their own
Sure.
microgrid, which is having also a storage, which can store the energy inside. In fact, we have, as HAPG, Hitachi ABB Power Grids factory, we have a microgrid in our factory with the battery
Sure.
storage, and it's connected to the system. And going forward, we'll also be seeing, let's say, hydrogen fuel cell based, the generation inside the industry, inside the plant. And so you can gradually reduce the diesel DG power. Then you can have this renewable solar PV, hydrogen fuel cell. They are connected, and like we have technology called eMesh, where all these different distributed energy resources, they can be connected in real time, they can be controlled, they can be protected, they can be also running on the AI ML based algorithm applications, by which you can really make the power available. Important, because in a power scenario, few millisecond counts, because if there is any disturbance in the system, anywhere in the system, and in tens of milliseconds, it can lead to a failure, cascaded failure inside the
Sure.
plant, or maybe inside in the area, in the city, or in the state, or in the grid, national grid. But I
Okay.
think with having this core technology, renewable automation, and digitalization, extending to digitalization, IoT, industrial IoT, I think we can make it really sustainable, and moving more towards carbon neutral future. So, yeah.
Okay. Whenever we talk technology, we have to talk security. And this is a question which is open to the entire panel. But Amit, if I could maybe come to you first. What really are we talking about when we're talking security really of these smart grids? What should we keep in mind? What should we perhaps be putting in place when we're talking about, security really of the smart grids?
Right. See, the reason you're asking this question also connects to the journey which I was talking earlier, because till now we were focusing on large-scale solar parks and large-scale wind plants. But now, with the solar rooftop and decentralized energy becoming commercially viable, and even if you look at the Government of India targets, out of 100 gigawatt of solar, 40 gigawatts is only on solar rooftop, and a sizable amount of that will be installed on the homes, the industrial complexes where we all live. That's why the security which you were talking about becomes of a real big concern, so that when you're installing a big equipment like solar rooftop and you're connecting that with your net metering connection, where does it lead to in terms of a security? So it's a very important aspect. When we go towards these decentralized energy, security becomes the foremost and the criteria before we go for these systems. And uh, at the World Bank, we have a $625 million project with State Bank of India, where we are giving loans through SBI to solar rooftop companies who provide these systems along with the security aspects when they install the decentralized energy systems. The second aspect
Okay.
we are doing is the Government of India, MNRE, is doing a unified web portal. So it's an online portal in almost every state, where you not only install these systems, but you also share data with the Government of India in a spin portal, and where you can also analyze the security aspects
Sure.
of these systems.
Sure. Sure. Mr. Tripathi, is that something you would also be in a position to comment on?
I agree with him that these are the areas for future expansion, and areas that challenges may be listed. But if I can add a few more challenges, coming back to that issue raised a little earlier,
Sure.
I find that post-silicon technology is going to be a challenge, because at some point, the way technologies are moving, we have to get used to a scenario, beyond silicon what, and then the cost. If you look at the way cost is coming down, that is going to be a challenge because, today, in fact, Amit was referring to the, Charanka Park and the bigger parks and the cost in India, the way it is coming down. Now, 2 rupees for fixed for next 30 years. Now, if you discount at 4%, which is the minimum post-bank savings bank rate you get, and at the end of 30 years, it is around 28 paisa. Now, if you can imagine, after 30 years, you are getting 1 unit of electricity for 30 paisa, and for 30 paisa, you will get nothing else. This will be the cheapest commodity at that point of time, and that is called electricity.
Okay.
Now, that is going to be a challenge. And the way, technology is moving, 3D printing, for example, or plug and play, the type of new panels you are getting, not only bifacial, smart, long silk cottons, you are getting new types of panels in the market. And we are also going to get a challenge managing of data in this sector. And, when we are talking about International Solar Alliance being an OPEC to manage the one sun, one world, one grid, which will have a world treaty to manage itself and which will have a world grid code. We are talking about a grid code, we are talking about a world treaty. And in this scenario, when the entire world is one single energy market, that is a challenge to manage the big data mining that we are talking about. And how it will affect the common man. In fact, the prepaid technology, you put a meter and you pay in advance. Now, many people are not used to that. So this is going to be a challenge. You have to manage technology change, and you have to manage the people who have to change along with the changing technology. And that is not always a very simple thing. And the type of manpower that the next decade will require to a changing world, when we are talking about 100%, with solar. Of course, we include solar derivatives. Like we always say, the World Solar Bank will give loan for wind projects even, because they are solar. It'll give for green hydrogen. It'll give for storage projects to make it more broad-based and more inclusive. But today you have only around 3% of the entire global thing solar. We are talking about a world run with 100% solar. And then what is the amount of money that we need? One World Solar Bank with $100 billion is not going to be adequate. So if we have a series of things, these are going to be challenged in the area of land management. There are countries who have no land, countries who have vast amount of land, and even the countries, because of location, how much you can exploit the land for sun or solar purpose. There is a challenge there. You have challenge in capital distribution. You have challenge in technology. And those are the challenges we are talking about. The last challenge, of course, after a decade will be how to manage the solar waste.
Yeah.
Sorry, I'm just adding on to DG Tripathi, if I may.
Sure, please go ahead.
See, as DG Tripathi mentioned very nicely, the questions on renewables being the future is gone now. That's now understood and taken by everybody, by institutions, by everybody. We are going to be moving towards renewables very, very fast. What now we are talking about, how fast we can move in technology, how fast we can move in IT. When DG talked about 3D printing, when he talked about looking at solar rooftop on every household. So when the technology is moving very fast, we will see how IT is catching up in terms of these technologies when we are moving towards that direction. Again, as DG mentioned, now we are not talking about renewables everywhere. We're talking about, can the one sun, one world, one grid, can we have the interconnectors between different countries and different continents to transfer this power one part to another? One simple example, because Gujarat and Rajasthan has large desert, it is natural solar in because you have to either transfer this power to Delhi or to Maharashtra, because these are the demand centers. But can we also look at exploring the transferring of this power to Gulf through interconnectors, right? So this is where the technology will play a huge role in determining, can the renewable power be transferred between states and to different countries and to different continents.
May I add to this?
Please go ahead, Akhilur.
Yeah, so this is about, we are talking about OT and IT integration, and you raised a very valid point of cybersecurity, right? I think here automation and more connectivity to the cloud with the devices, with the sensors, with the controllers, actuators, and all this in place, I think it's very important because compared to the IT system where our security goal is confidentiality, integrity of data, and availability of the system. This is the sequence. Whereas in power, in the utility, it is availability is first. It has to be available, integrity of the data, and confidentiality. It's the sequence is reversed. Earlier, it is like CIA, we call it confidentiality in IT, confidentiality in integrity of data availability. Here it is AIC. Because as we talked about, if the system, if the device, if the particular equipment, whether it's a solar panel or transformer or circuit breaker, if
Sure.
it is not available, and it can lead to failure of that line, it can also lead to a cascaded failure of the entire system. Maybe it's a city or state or national grid. Okay. So here, I think very important that we have been doing also is that we test all our communicable devices which are coming with the primary equipment with the cybersecurity robustness testing. We ensure that even if there is a cyber attack, either it's a malware or it's a intended attack, the device is still able to sustain it, still able to operate. It should be a fault tolerant kind of device. From devices to connecting it to the controllers, to the SCADA. So the entire system is tested in a way that we know that if there is any intrusion, any attack, the system can still work. At the same time, it can isolate the attack. So that is how we also bring in a very strong philosophy of doing a threat modeling of the entire system. The way the system evolves with a lot of connectivities, with IoT, with cloud connectivity, do a threat modeling, and then come up with a defense in depth kind of approach where you try to, like a defense in depth, it comes from the defense actually domain, that you create a core system with network which has to be in any case protected. Otherwise, the entire thing will go haywire in the sense it can lead to a blackout of a state, for example, state grid. So you have to, protect that core, and then you create a ring around that fencing so that it's like a, virtual fencing, and you detect any attack, any cyber security issue, and isolate it, and also make the system still running. The other thing is very important, which also the utilities they have to now take care, is that it's not just one time. If I provide a device, equipment, or sensor, or actuator, controller with cybersecurity tested with a good design of the system, that doesn't mean that it's not the way in the office. We have to always continuously do the operation of the system, ensure that the system is updated with antivirus system. It is hardened with respect to any ports open, or it also has to be continuously updated with the new software. It has to be also tested, validated. Also there should be monitoring of the system with respect to any intrusion, and also doing analytics. I think it's holistic approach, right from the device endpoint to the system, to the network, to the cloud, to the the AI ML application what we are running, and also at the same time installation of the system, whether it's a solar installation or microgrid or smart grid or entire state grid. Installation, operation till its life, end of the life. It has to be done on a continuous basis, and the utilities they have to be prepared for that. And there are procedures, there are also techniques, technologies available to protect.
All right, Akhil. We're running out of time on this conversation today. I very quickly want to take our last poll. Would carbon emission in India drastically reduce with IT and OT integrated smart grids? That, of course, is up on your screens. You need to respond yes or no. Would carbon emission in India drastically reduce with IT and OT integrated smart grids? With that, let me take very brief 20-second closing comments from the four of you. If there is one thing that you think we should definitely be keeping our eye on when we're talking about the future as we see it, as far as power, as far as renewable energy is concerned, particularly given the size of the opportunity that's present in India, what really would you want for us to look at? Open to the four of you, but let me start perhaps by giving Mr. Tripathi the opportunity to give us his closing comments first.
Thank you. In fact, it is not a dispute that we need more ITs, and IT and artificial intelligence are going to play, very strong role in future. But the type of manpower that we need is very critical. And if you are thinking of a time frame of next 10 years, next 15 years, we need a very strong IT skilled, IT aware manpower that will look into various service sectors in the expanding solar sector that we need. And that is to be
Sure.
very carefully planned by the member countries. It is not merely a question of getting employment to people, but this is very critical at a time where everything is smart, and smart technology requires smart mechanics, smart working people, and everything has to be smart around the smart ecosystem. And the manpower over the next 5 years that we are talking about, as solar energy spreads, is it is not only smart IT or smart applications, but we are talking about smart people.
Okay, Amit, could I come to you next?
See, it is very clear that India is a global leader in when it comes to IT with Infosys, TCS, Cognizant, right? We have proven that, and as DG mentioned, that there is a natural IT and software infrastructure within India. At the same time, the convergence of technologies which are going to impact every human being is looking at the renewable energy future. Our cars, our roofs, the smart electrons which are it's going to impact our life. So we are looking at a big opportunity and a challenge when we can translate the software and the IT expertise we have, and we start to implement that in the renewable and sustainable energy future which we are going to live.
Okay, Biswadeep?
So my point would be that a new mindset is also required. With the
Okay.
evolution in the sensors and the cyber physical devices, with the evolution of the IT and the convergence of IT. And by the way, convergence is not a point convergence. It is a line of convergence. It is a journey that takes place. But what we need is a new mindset. It comprises how your brain captures the new context and defines how to act and decide. Now, designing and developing the correct mindset ensures that these behaviors and decisions are shared by all the organizations, right? So we need a culture of innovation, and to get inside this digital transformation era. So this is of huge importance, because the digital transformation or IT/OT convergence, it is changing the business game by introducing new techniques and the
Sure.
mindsets that support a new environment, where these business models or these operational systems, they create new value proposition, and that
Okay.
challenge the scale and the world we now know these days. So mind technology.
All right. Akilur, I want to give you the opportunity to have the last word. Please go ahead.
Okay, I would change this statement a little bit. I think it's all about convergence of OT and IoT. As I
Okay.
gave a lot of examples about, IT has been there in power systems, in the power network, much before even the enterprise IT was there. I can tell you. I mean, there's several decades, because the power system, the nature of power systems is such that it has to be real time. So it's all about how I can embed the IoT with OT, and a lot of digital technologies, automation has been there. I mean, some examples I'll give you. We have a robot which can go inside a transformer to do the inspection when the oil is still there in the transformer. So normally, what the utilities they have to do, transformer being very important, so we call it T-Explore. So they used to evacuate the oil from the transformer and then open the transformer and do the inspection, which used to take several weeks. Today we have robot. You don't have to actually open the transformer, in the sense everything. You don't have to evacuate the oil. You can just send the robot, and it is real. Actually, we have done in December in one of the steel plant in India. We
Uh-huh.
have done several. So it goes inside the transformer and it does moves around. We call it diver robot. It is our own technology. So it goes inside, and then you can monitor sitting outside or sitting remotely that what has been there inside the transformer. What are the defects?
Sure.
What are the gases? What are the insulation? What are the so that is there. And I think it's all about when we want to make it operational, make it successful, I think it's about co-creation and collaboration.
So the opportunities definitely are immense, and the
Yeah.
opportunities and the future definitely looking bright, gentlemen. I want to thank the four of you for taking the time to join us on this conversation today. Thank you once again.
Thank you.
Thank you very much. It was nice.
Thank you. Thank you.